Okay, good morning everybody and welcome to the Virtual Malvern Science in the Park this morning. Great to have you all here. Obviously it had a lot of rain just earlier and so we were very pleased that we weren't actually setting up in the park. It's been a bit of an experiment, so bear with us today as we do our best to deliver to you a whole range of different scientists joining us from around the country. Couldn't be possible, of course, without a lot of support. So we're particularly thankful to the sponsors that have supported us today and also helped with putting this together and doing a few of the tech run-throughs. Okay, so first of all, I'd like to welcome Professor Mcleod. So he's a scientist down at QinetiQ, which is one of the big employers here in Malvern. There are a lot of scientists based here in Malvern, and Malcolm's very kindly agreed to say a few words to officially open the Science in the Park event today. So thank you, Malcolm, for joining us.
Thanks, Adrian. Well, it's great. Thank you for asking me. I'm really pleased to join it. And as you say, we're probably quite lucky, really, to be using Zoom, given the possible rain. It's lovely. I came to the Science in the Park last year and I was really impressed with all the stalls, and I've seen the program for this year and I think it's very exciting. So I hope the people who are watching this now will manage to see lots of the very interesting talks that are coming on. You asked me, Adrian, to say a little bit about my experiences of science. I started with fascination when I was really very little with how things work. And that was both how machines and things designed by humans worked, but also when you look around, there is just so much that is fascinating. You know, why are clouds the shape they are? Why do tides work? Why are flowers and plants, how do they form these shapes? And in fact, even today, I'm still slightly amazed that plants grow every single year. I keep saying to myself, where does all this material come from that makes these rigid stems and these large leaves, comes out every year, dies again the next year, and then there's more of it. Now, obviously, eventually I learned that plants extract carbon dioxide and other materials from the air, and they actually build solid chemicals from gases. But I was just fascinated by how things are and how they went on. When I was very young, I had kits to build models. There was a thing called Mcleod, which I think still exists, but I'm not sure whether you'll all have heard of it. But you used to be able to make model motor cars, model fairground attractions, all sorts of machines with it. And then I got interested in electric things like light bulbs and motors. I made plenty of mistakes. I once tried to test a Christmas tree light bulb by connecting it straight to the mains, and of course it blew up. And my mum very patiently said, I think we'd better wait until your dad comes home and you can discuss it. So I began to learn about electric circuits and electric motors. And then for me, I got very interested in electronics. And at the same time at school, I became very fascinated with mathematics. I love mathematics. I think it's a wonderful subject. And it's pretty important, whatever branch of science or engineering you're in, it's pretty important to be capable enough at mathematics, even if you don't, like me, actually rather love it and love doing it. So I went on and I went in the direction of engineering. I did an engineering degree. But of course, people can do degrees in what we call the physical sciences, you know, physics and chemistry, or the biological sciences. And whatever you're doing in science and engineering, I'm sure that the reason it's such fun and is very enjoyable is just the sheer fascination of it, the sheer satisfaction of learning how something works. If you go in the engineering direction, you're interested in learning how to design things, you know, electronic circuits, machines, biological materials in pharmaceuticals that will work. If you go in the direction of studying sciences, it might be because you're more interested in how does the real world work, how does nature work. But for me, it's always been about fascination and enjoyment and often just the fun of it. I remember at school in Fates, we used to do scientific tricks, and I'm sure there would have been plenty on show today in the Science in the Park if it had been running outside. But I remember how enjoyable it was to suspend ping pong balls on a jet of air flowing up vertically from a nozzle. So the ping pong ball is just there in the middle of space, spinning round and just sitting there. And it's like magic. In fact, before today, I looked up a few quotes. I was thinking, well, what have other people said about science? Because science and technology are so massive. There is so much of it. Has anybody managed to sort of encapsulate it in a few sentences and say something really good about science? Well, the answer is that a lot of people have. I looked lots of quotes up on Google, and of course I'm not going to start reading all those quotes, but you can do it as well. If you stick in words like science is like into Google, you'll get all sorts of quotes. But there were a couple that I thought might be worth me mentioning because they tie in with some of my own experiences. There are lots that say things like science has great beauty, or science is the poetry of reality. And I think the reason people say things like that is to point out that science is not just boringly turning a handle. There is beauty and poetry in it. There are times when you get a tingle in your spine because you realize something and you think how wonderful that is, how exciting that is. I found a quote which I really liked because it seemed to me that it's something that we can take on board if we're interested in science, whether we're interested in the study of pure sciences or whether we're interested in technology, as I am mostly. And it was the quote, somewhere, something incredible is waiting to be known. Now, I think that's a really good one for scientists. And if you're really more interested in designing and making things, I think all you need to do is change the last word to designed and say something somewhere incredible is waiting to be designed. Because the real excitement of all this is it's going on and it's almost getting faster and faster. The technology that we're using in this Zoom, even though I've worked in electronics and communications and computing all my life, I still find it simply astounding. When you think of the millions of pixels on the screen being encoded by mathematical algorithms and then going through lots more maths and electronics just to get from my computer to my Wi-Fi router, and then more of it to get along the cables to the telephone exchange and so on. I mean, it's just amazing. And of course, this is a Zoom call, so the whole lot is going via America. And when you think of all that, the fact that there are loads of us on this call, all our video is being encoded, it's all being shipped to America, it's being mixed together, and it's all being sent back. I just think that's incredible. We all think of Albert Einstein as one of the most famous scientists. Well, of course, he is one of the most famous scientists. And I thought there was a lovely phrase that came up when I was searching. Albert Einstein said, "Imagination is more important than knowledge." And I think that's worth remembering if sometimes you struggle with the sheer slog of learning lots of stuff. I remember at school that a lot of subjects seem like just learning stuff. And you don't always immediately know how wonderful it's going to be able to use it at the end of all that. So I think it's worth remembering what Einstein said. When it comes to it in the end, your brain's ability to pull stuff together and to imagine stuff is more important than simply how much you know. I think that's especially true these days because you can just go onto Google and other sources and the literature which you can obtain over the internet, and you can find out bits of information, but it's your brain's ability to spot something the way that people did when they first realized the structure of DNA. The information was there. The magic step was someone's brain simply clicking and saying, I know what explains that. It's the double helix. So imagination, it's worth thinking about that, and don't let anyone persuade you that science is all boring handle turning. I remember a phrase, and I've sometimes said this to young people I know who talk about how much there is to learn. I remember hearing a phrase, but I couldn't find it on Google, so I don't know who said it, but they said science is like a glorious hall, but it's approached through a very long dark corridor. And sometimes, you know, being at school and thinking about science or reading about science, it just feels as if you're having to plow through so much stuff. just try to remember what a marvelous thing there is at the end of it, and how lucky we really are with our science and technology. So I hope you all enjoy the day very much. I'm certainly looking forward to it as well. And thanks for inviting me, Adrian.
Thank you very much, Malcolm, for opening the event today and for giving us that whistle-stop tour through all the different types of sciences and why they're interesting. And indeed, today we're covering a lot of those. We've got